Okay, so step 3 is to make these calculations. And I know that, again, probably this will be a little bit difficult to see in the video because it's a lot of information. Use the handout as your guide. You would have these available to you for quizzes and exams at this point in the course anyway. So this would be the point in the course where you would no longer have to have formulas memorized, just because there's a bunch of them here. Even though mostly they're hardly worthy of the word formula. They're pretty basic, most of them. So I'm just going to quickly talk through them. So again, in step 3, again, you wouldn't have the formulas in the boxes. This is where you would be writing your answers. So what I generally do is I just go down one column, go down the next column, go down the last column, go to the end over there. So again, this is analysis of variance. What we talked about was getting the total amount of variance for the entire study and then analyzing it, breaking into between treatments variance and within treatments variance. Well, variance, since chapter 4, is sums of squares divided by degrees of freedom. So to get total variance, between treatment variance, and within treatments variance, we need a sums of squares for all 3 of those and degrees of freedom for all 3 of those. So we'll see these in action when we get to the now let's do a problem from the book part. But probably the most complicated calculation of all of them is this very first one here, the sums of squares between treatment conditions. So what this says is you're going to sum up these fractions, treatment total 1 divided by sample size 1 plus treatment total 2 squared divided by sample size 2 plus treatment total 3 squared divided by sample size 3 minus the grand total squared divided by the total number of scores. Notice that this g squared over capital N is in 2 different formulas. So it's a good idea usually when you're working those to make a note of that in your scratch work somewhere so you don't have to recompute it. We'll see this exact same thing, capital G squared over capital N. It will be in 3 formulas next week, so it's even more useful to hold on to those. So this is the trickiest one generally. So for most of ours, we're going to have 3 treatment conditions. So it's fraction 1 plus fraction 2 plus fraction 3 minus that fraction. Down here, we're simply going to get the sums of squares for group 1 plus sums of squares for group 2 plus sums of squares for group 3. Simply sum up all the sums of squares values for each treatment condition. So that's a very simple one. And then this, the total sums of squares for the whole study, this, while this is written a little bit different over here with the g squared, this is the same formula since chapter 4 as well. Remember, what used to go there is the summation of scores, raw scores in parentheses. Well, the summation of all the raw scores is g. So it's the same exact formula, but for the entire study. Now, here's one of the beautiful things about these these results tables. If we take a whole thing and divide it into 2 pieces, if I take a whole apple and I cut it randomly into 2 parts, when I put those 2 parts back together, it should equal 1 whole apple again, right? Well, this is for the total study, the sums of squares for the total study, which we're then cutting into 2 parts, this one and this one. So there's a nice way to check your math here. After you've calculated all 3 of these boxes, stop and do a reality check. The result from this box plus the result in this box should equal this box. If they do not, you have at least one calculation mistake somewhere. So check that and make sure that this box plus this box equals what's in this box. Now, that does lead some students, particularly some clever students, to try to take a shortcut here. I just mentioned that this is the more challenging formula really for the whole chapter. It's not hard, it's just a lot of grinding. It's a bunch of work to do. So what some students want to do is calculate this box and calculate this box. And then the total minus this part should equal the other part. They just want to subtract their way to this answer. I'm telling you right now, don't do it. It is a mistake. It's easy, but what's the hazard? If there's a mistake in any one of these boxes, when you subtract it, you also now have a mistake in this box, and you have no way of knowing it. You have no way of catching it. So it's usually, not always, but it's usually the students that are doing pretty well and feel pretty confident. They're like, forget it, Paul. I'm going to go ahead and do it my way. I'm just going to subtract it out. And I'm telling you, every semester it bites some student that's killing the course, getting an A, and they're just doing really well. And then they get to this and they try to take the lazy way out, and it bites them. It will bite you sooner or later. So don't be lazy. calculate all three boxes, and then see if they add up properly. Now, once we've got this column done, we can move over to the degrees of freedom column, the easiest column in all of it in a lot of ways. Degrees of freedom between treatments, well, instead of our n minus 1 that we normally have, number of scores, it's the number of treatments minus 1. So just k minus 1, that's it. Down here, degrees of freedom for within treatments, degrees of freedom for the first sample, plus degrees of freedom for the second sample, plus degrees of freedom for the third sample. So just like the box next to it, add up all three sums of squares. Over here, add up all 3 degrees of freedom. And then lastly, degrees of freedom for the entire study, capital N minus 1. And once again, if this is the total, the 2 parts should add up. So the number you have in this box plus the number you have in this box should equal what's in that box. If it does not, you have a mistake somewhere, at least one. So it's good to, again, double check your work before you move on. Once we're happy with all of those, then we can move over to the mean squares column. Again, it's just saying variance. So mean of squares between treatments is another way of saying variance between treatments, which we know is our numerator. Well, how do you calculate variance? Sums of squares divided by degrees of freedom. So how do you count variance for between treatments? Sums of squares between the treatments divided by degrees of freedom between the treatments. Next row, the same thing. Our mean squares or variance for within treatments. Well, sums of squares divided by degrees of freedom. So now it's your sums of squares within treatments divided by your degrees of freedom within treatments. Notice the table is even handily arranged. The numerator is on the top line, the denominator is on the second line. It's arranged just like the formula is, numerator, denominator. Also notice that really all we're saying for this box is this box divided by this box equals that box. This value is what's in the numerator, this value is what's in the denominator. So really you're just going to calculate this, and then divide it on across. And same thing there. Now notice we've got this box shaded out. It's not that we can't calculate it, it's that we don't need to. Technically, we could calculate this, simply divide across like we did before, but this value doesn't do anything in the hypothesis test itself. So it's a needless calculation, so we just skip it. We could do it, but again, it's worthless to us, so we just skip it. Now, off to the right-hand side of the table is where we put our final answer. It's critical that you make a box for the final answer, for your F statistic or your F ratio. Students are often, almost always really good about building the results table, and then they put the final answer, the most important answer, I don't know where. They hide it somewhere on their paper, and I have no idea where the answer is. Again, it becomes a treasure hunt for me, and that's bad news. You don't want me having to play hide and go seek with your answer. So we want to make sure it's right here, right next to the table. Now notice that with the F ratio, in parentheses next to it, and again, it's just like it shows on your formula sheet here, degrees of freedom between treatments and degrees of freedom within treatments. That always gets reported with all F ratios, all F statistics. Both degrees of freedom values are always with it. So we're used to putting that in our APA decision notation, but it goes everywhere now. So an F, we would say, of this and that, an F of 2 and 10, or whatever the numbers would be, equals, and then the formula for that, we already knew. That was one of the first videos we had. The numerator is your variance, or mean of squares between treatments, this box. The denominator is mean of squares within treatments. Again, I'm sure that's difficult to see. Look at the formula sheet handout. So again, this box divided by this box equals what's in that box. So this is a very useful tool for you. It's a good roadmap. If you're working on it and you're so buried in it and you're like, I'm not sure what to do next, look for the next empty box and start grinding that math. It's a roadmap for what to work on first, second, third. It's a way of double checking your math. It's a way of correctly giving me all of your answers. Now, the last thing I want to say here is that obviously when you're doing this online for both a quiz and an exam, you need to build the table. There is a table building tool right inside the exam or quiz module. So where you would go normally to work on a hypothesis test, it's almost like an essay, blank box, where you type in all your stuff. What you're going to see is, and there's instructions online for this with the quizzes and whatnot. I'll make an announcement for it, hopefully to remind everybody as well. You're just going to tell it to draw a table, and you're going to want it to draw it 1, 2, 3, 4, 5 columns wide, and 1, 2, 3, 4 columns or 4 rows deep. 5 columns by 4 rows. You'll have some extra boxes over there that you don't need. You can just leave them blank. And then you just label, and then just type your answers in there. Now, one last thing here. Remember, one of the things we started dealing with was rounded values. What do we do about our rounding? Our rounding rules remain the same as always. If your answer contains a decimal, you must report it rounded to 2 places. What you're going to put in this table are answers, if they need rounding, rounded to 2 places. But when you are computing, you use the full value, not the rounded value. So for example, if we're going to compute our mean squares between treatments, it's the value in this box divided by the value in this box. Well, this will always be a whole number because it's always a whole number of treatment conditions. But this may very well be a decimal. We would have written the rounded decimal in here, but when we're dividing, use the full number. What we can see is if you calculate with the rounded number, this answer will be off a little bit. Now imagine you had to round somewhere in here, and now this answer is off a little bit. And then you divide this answer by this answer and round again, and now the final answer could be off by as much as 1/10 of a point, which could make a difference in your decision. So as always, report rounded values, but make your calculations with unrounded numbers. That means you either have to get good at using the memory or storage function in your calculator, or in your scratch paper, keep track of all the unrounded values. Out to, I would say, 5 or 6 places is plenty. If you write it out to 5 or 6 places and just sort of cut it off there, you should be fine. Anything rounded past that won't affect us to the 100th place. So don't forget to do that, because some problems it will absolutely make a difference. Some it won't make much difference, if any, and some it can make a big difference. So calculate, report rounded, but calculate with unrounded. Okay, off to step 4.